Year 10, 11 we're off the air. Because I've hinted at how we solve these ones, but I haven't actually gone through an example. So the one I'm going to go through, obviously we've been through these examples here. We've got root 2 on 2, we've got negative root 3 on 2, and we've got negative root 3. So check those three answers. But the last question of our warm-up, 2 reasons I've run out of room, and number 2 is I want to really explicitly go through how we deal with these problems. Try and identify and deal with some misconceptions. So the first thing that I notice when I deal with this problem is what's the key difference to what we dealt with before?
Negative.
The angle's negative. Okay, and what does that mean? It goes the other way. So instead of going counterclockwise, 3 pi and 4, it's going to go clockwise. So it's going to go 3 pi and 4 this direction. Are we happy with that? The process from here is much the same. We know that's 3 pi and 4. So what quadrant am I in? The third, the tan quadrant, which is going to make my answer negative sine theta k. Now I need to find out what my theta k is. And what is my theta k? You might call something different. I call it my key angle. What's my key angle there?
Pi take, is it just pi take away 3 pi and 4?
It is. So I want the difference between pi and 3 pi and 4. Okay. I consider that angle there is equal to pi and 4, which is exactly what you're saying. So my key angle there is pi and 4. So I just sub in my value equals negative sine pi and 4. And then from there, I just go to my triangles and use it. Clear? So the only complexity is drawing it and identifying what's our key angle. We don't want to let misconceptions like the negative theta k fall into it. We just find out where it positions itself on our plane, on our unit circle plane, and go through the same process. From there I draw my triangle. What triangle am I using?
60K.
Yeah, the 45, 45 with the pi and 4 with the big boy radian pants on. And we get opposite, doesn't matter which angle we choose, opposite over hypotenuse, which is negative 1 on root 2, which we can rationalise to be negative root 2 on 2, which is how you might see it in your textbooks. Clear? Happy with that? So what's the trick with negative angles? They simply go the other way, the process is exactly the same. There's no reason to panic. I think question 3 is much harder when we've got a full rotation. That's much more complicated than that. What's something that makes this a lot easier though? What's the step that makes that a whole lot easier? Did anyone struggle with that question? When I went through it, just ended to make a lot more sense. What part of the question do you go, I get that now? Because I reckon it wasn't at the end. I reckon you had that aha moment earlier. When was it? Jason, when was it for you?
When I realised it went the opposite way.
Just the drawing, hey? When you draw that out, it makes it a lot clearer because you can deal with... If I didn't take that, if I just gave you that angle there, you'd know what to do, providing I said sine. Clear? So drawing it out obviously makes our life a bit easier. We're going to do some practicing of our drawing. Now remember, we're in the domain of 0 to 2 pi. So you might get 1 period, you might get more than 1 period. And for question D here, I haven't taught you about the horizontal shift. We will be running through that today, but I don't want to take away the opportunity for you to figure something out on your own. So I really want you to have a go at figuring out what that looks like. If we're not sure with functions, what's always something we can do? What's a strategy we can rely on? Without using calculators and decimals, they are good strategies, you're right. And if it was an exam, I'd say absolutely do that. Not an exam, we're trying to develop an understanding of horizontal shifts. What's something I could do?
Look at other equations.
I could look at other examples. Could I let x equal something? What could I let x equal?
1.
Yeah.
What could I let x? What's the first thing you should let x equal? 0. Let x equal 0. What's cos of pi on 2? 0. So this function is going to equal 0 when x equals 0. Then I can let x equal pi on 2. See what happens after that. Does that make sense? Let's keep going.